Space, too vast to comprehend. For millennia, we have gazed at the stars, trying to make sense of our place among it all, trying to find out how it all works, all from the comfort of our cosy little blue speck. This fascination led to the creation of telescopes, which allow us to see further than we have ever seen before. Gazing right back to the beginnings of our universe, admiring the beauty of our night sky, it's hard to imagine the terrifying forces at play. Battles of nature on a galactic scale. The creation of life and the death of stars are commonplace on this stage. One of the larger characters in the story of our universe comes in the form of black holes. We know very little of them, and our understanding of the universe in general is small. But that does not prevent us from theorizing. These wonders of the universe consume with an immense gravitational field. They devour everything from matter to light. We have no idea if they are 2- or 3-dimensional in form. Current thinking is that for most of them, they are born from a dying star. Nothing can escape the massive forces of these behemoth giants, not even time. As a frame of reference, think, if you will, of pulling the plug from a full bath and watching as the water is uncontrollably pulled into the void. A smaller comparison for sure, but this gives you an idea of how nothing can escape its grip. Their purpose is unknown. It's thought that supermassive black holes exist at the centre of our galaxy and are what pull them into their respective design. To put it another way, the Earth's density would be condensed into something smaller than the size of a tennis ball, a lot of power squeezed into a small space. For a black hole, this small space is the centre of which all matter ends up. This space is called singularity, infinitely dense. No one knows for certain, but there are theories about what exists past the event horizon and the singularity, what lies past the point of no return. Here are 5 theories on what's on the other side of a black hole. They create other universes. One theory suggests that the matter that is pulled into a black hole is eventually spewed out the other side in the form of a Big Bang. A Big Bang is the current go-to of how our universe began. This theory would mean that for every black hole in existence, there is another universe on the other side. We would live in a multiverse, an infinite amount of universes, which themselves are continually creating the new or next generations. Lee Smolin, a theoretical physicist based at Canada's Parameter Institute for Theoretical Physics, has stated that when a star collapses into a black hole, it very quickly squeezes down to infinite density and time stops. This is based on the concept of general relativity. What Smolin suggests is that the stopping point can be deferred using quantum mechanics, and rather, the star collapses to a certain extreme density and bounces back. This bounce causes an expansion, and this expansion becomes a new universe. The theory is based loosely on how nature reproduces itself, a cosmological natural selection. If you think about it, this theory sounds plausible. Think of a woman creating a child inside her. The woman consumes food, which is matter. This matter is absorbed by her body and used as energy. This energy is then used to create her child, a new life. Our creation just has an extremely long birth. The rebirth of our own universe. This theory shares similarities with our last point, and based on a concept called the Big Bounce. Similar to an accordion being played, contraction, expansion. The birth of our universe and black holes share something in common. The singularity that we spoke of in the introduction. A place so infinitely dense that we cannot even comprehend, let alone understand it. Both share similarities in that they are a place where all its matter lies. What if all the black holes in our universe slowly merge together and eventually consume all matter and light in the universe? That singularity would theoretically hold everything that ever existed within it. If that is the case, then our black hole's singularity, on having no more matter to consume, could blow out our dead universe and give life to a new one, our own universe being continually recycled forever. It sounds like a beautifully natural solution to the theory of how our own universe was created, and is a slight spin on our last point. They are the hiding place of highly advanced civilizations, We know that our own civilization seems to find it impossible to live without our precious fossil fuels, but we like to think that our universe is vast enough that at least a handful of civilizations took the correct path and were forever striving to harvest their own natural resources without endangering their environment and its people. This civilization would be Type 3 or more on the Kardashev scale. The Kardashev scale is the method of measuring a civilization's level of technological advancement based on the amount of energy a civilization is able to use. Planet Earth hasn't even hit Type 1 yet. For the subject matter to even be possible, there would need to be a black hole the size of our own solar system. The reason for this is that the surface of a black hole becomes less extreme the larger the black hole is. This supermassive black hole would have a large enough stable area within the event horizon to hold an entire planet within, and this would orbit the central singularity without being torn apart. There is a particular black hole that is suitable for this type of scenario, a Resner-Nordstrom black hole, which is both charged and rotating. Russian cosmologist Evgeny Dokoshev hypothesizes that beyond the event horizon in this stable area, a planet would be capable of lying in a normal state. This planet would receive all its energy and life-sustaining needs from the illumination of the singularity. It would also be the perfect place to hide from other, less evolved or war-driven species, like us. They transport matter to another part of space-time. Let's say the black hole is like a wormhole, similar to what's seen in Star Trek and Interstellar. The idea of covering vast amounts of distance in a fraction of the time is an appealing concept. If space-time was a sheet of paper and we were trying to get from one side to the other without crossing the entire sheet, a wormhole folds the paper until both points meet and punches through one point to the other instantly. What science fiction fails to mention is that we may not know where we end up at any given time. Black holes may be in a constant state of flux, changing their direction. We may never be able to control where we end up. As you previously heard, this theoretical black hole is a passageway to another part of space, or even another universe. This new theory is based on a concept called looped quantum gravity, but let's call it LQG for short. It merges quantum physics and general relativity in an attempt to fix some of their incompatibilities. Under the LQG parameters, a black hole does not have a singularity. When numbers were crunched by researchers from a university in Uruguay, they found that when energy was pulled in and squeezed, it suddenly loosened its grip, as if a door was opened on the other side. LQG black holes are less like holes and more like passageways or tunnels. Tunnels to either different parts of our universe, or even different universes altogether. It sounds amazing, but I don't know who would want to be the first one to try it out. Nowhere, it's a hologram. Physicists and scientists alike cannot agree on whether our black holes are three-dimensional monsters or flat, two-dimensional surfaces projected in 3 dimensions, like a hologram. The fact is that we are limited to viewing some of these objects from millions of light years away, and only from one approach, one angle of view. It sounds like an impossible task. Just let your mind accept the notion that our cosmos does not lie in 3 dimensions, but rather 2. This would mean that when matter and light are pulled into what we see as black hole, is in fact getting stuck in the gravitational fluctuations of the 2-dimensional surface. This analogue was used. Imagine a basketball loop. The ring is the event horizon, and the net is where all matter falls and disappears. Now push the net up to the ring to make it a flat, 2-dimensional surface. There is no inside, and there is no other side. So that's 5 mind-blowing theories on what could be on the other side of black holes. A truly fascinating topic that never ceases to amaze. Take 5 minutes of your time tonight to just look up at the sky and be consumed by wonder. Thanks for watching, and I'll see you in the next video.